Volumetric analysis is a quantitative analytical method used to determine the concentration of an unknown solution by measuring the volume of a standard solution required to react completely with it. This method is commonly carried out through a process called titration, where a solution of known concentration known as the titrant is gradually added to a solution containing the analyte until the reaction reaches its endpoints. One of the common applications of volumetric analysis is the determination of vitamin C, also known as ascorbic acid in orange juice. Vitamin C is an essential water-soluble vitamin that acts as an antioxidant, supports the immune system, promotes collagen formation, and helps the body absorb iron. The determination of vitamin C in orange juice is important because the amount of vitamin C can decrease during processing, storage, or exposure to heat, light, and oxygen. Therefore, food manufacturers use this analysis to ensure product quality, verify nutritional labeling, and maintaining consistency in their product. The determination of vitamin C in orange juice is commonly performed using iodometric titration, which is a type of volumetric analysis based on a redox reaction. In this method, vitamin C acts as a reducing agent, while iodine solution acts as an oxidizing agent. Vitamin C reacts with iodine in a 1:1 mole ratio, meaning 1 mole of vitamin C reacts completely with 1 mole of iodine. The chemical equation is shown below. C6H8O6 plus with I2 equal to C6H6O6 plus 2Hi. During the titration, iodine is added slowly from the burette into the orange juice sample. As long as vitamin C is still present, all the iodines reacts immediately with it. When all the vitamin C has been completely consumed, the excess iodine reacts with the starch indicator, producing a permanent blue-black color. This color change indicates that the endpoint of the titration has been reached. There are several important terms used in this experiment. The analyte is the vitamin C present in the orange juice. The titrant is the standard iodine solution, and the indicator used is starch solution. The endpoint is observed when the blue-black color remains permanently, showing that all the vitamin C has reacted.
And now I will explain the methodology used to determine the vitamin C content in orange juice. The experiment consists of 3 main stages, which is sample preparation, titration, and also data collection. So, first is the sample preparation. So, the fresh orange juice was filtered to remove the pulp and other suspended particles that could interfere with the titration. Next, exactly 10 ml of the filtered orange juice will measure using a pipette and then transfer into a clean conical flask. If it's necessary, a small amount of distilled water was added to make sure the solution is easier to mix. And then is the titration process. A standard iodine solution of known concentration was filled into a burette. The iodine was added slowly into the orange juice while the flask was continuously swirled to ensure complete mixing and reaction. And then, finally, the data collection stage involved recording the initial and the final burette readings to determine the value of iodine used, also known as the titrate value. The titration was repeated 3 times and the average titrate value was used to calculate the vitamin C concentration. In this slide, here we show you the procedure step by step. So as you can see, first the fresh orange juice was prepared and then the juice was filtered to remove the pulp and other solid particles. Next, exactly 10 ml of the filter sample will measure using a pipette and then transfer into a conical flask. And then for the fourth step, as the endpoint approach, a few drops of starch indicator was added, and then we add the starch near the endpoint because adding it too early can form a stable iodine starch complex, making the endpoint is difficult to observe accurately. And then next, the sample was filtered with the standard iodine solution while continuously swirling the flask. And for the sixth step is the endpoint was reached when the permanent blue-black color appeared and remained for about 30 seconds. And then this indicates all the vitamin C has reached completely with the iodine. And then for the seventh step, the initial and the final reading were recorded to determine the titrate value. And finally, the average titrate value from the three trials was used in the stoichiometry calculation to determine the vitamin C concentration in the orange juice sample. So, this methodology ensures that the determination of vitamin C is both accurate and reliable by repeating the titration and using the average titrate value for the final calculation.
This slide shows an example of the titration results obtained from 3 trials. The volume of iodine solution used in each trial is very similar, with an average titrate value of 10.17 milliliters. Since the results are consistent, it indicates that the experiment has good precision and the titration was performed carefully. Using the average titrate value together with the non-concentration of the iodine solution, the number of moles of iodine can be calculated. Because vitamin C reacts with iodine in a 1:1 ratio, the number of moles of vitamin C is equal to the number of moles of iodine used. The moles of vitamin C are then converted into mass and expressed as the concentration of vitamin C in the orange juice, usually in milligrams or 100 milliliters. This example demonstrates how volumetric analysis can provide accurate and reliable quantitative data for determining the vitamin C content in food products. In conclusion, volumetric analysis is a simple, accurate, and reliable analytical method for determining the concentration of vitamin C in orange juice. By using ionometric titration, the amount of vitamin C can be determined based on the volume of iodine solution required to reach the endpoint. The permanent blue-black color produced with the starch indicator confirms that the reaction is complete. This method is widely used in the food industry for quality control, nutritional labeling, and monitoring the quality of food products. Determining the vitamin C content helps ensure that consumers receive accurate nutritional information while maintaining product quality and consistency. Overall, volumetric analysis is an effective technique that plays an important role in analytical chemistry and food analysis.